The European Space Agency withdraws first official images of 3I Atlas, the passing interstellar comet Mars. The world hopes that everyone will detail it. What erupts instead is outrage, a blurry dot, silence from NASA, China, and the UAE, and no sign of the sharp data that everyone expected. Why was the most watched flight in a long time the internet-breaking Mars flyby only raising questions? And what exactly are the organizations cloaked in technical excuses? Backyard astronomers can produce images that are sharper than billion-dollar missions, and claims that they are impossible make the chemistry begin to whirl, but only one thing is guaranteed: the true story is only beginning. So, what are we not being told? At 9:22 UTC on October 7th, the first official ESA images of 3I Atlas dropped across agency channels. Within minutes, the world's biggest science accounts, space enthusiasts, and even the same meme pages were published with an inadequate frame, a faint, hazy spot less than half as bright as the digital noise within it. ESA apologies were popular by noon in 4 languages. Hashtags like #FuzzyDot and #WhereAreThePhotographs surged across X and Reddit, from seated position analysts analyzing each pixel. The disappointment did not stop the outrage. Side-by-side comparisons flooded in, showing backyard telescope captures with more obvious information than the billion-euro Mars orbiter. Comments alleged that ESA was concealing something that points to the silence simultaneously from China, NASA, and the UAE. Every unanswered question made the pressure for a real explanation only increase. The camera in Cassis aboard the Mars Trace Gas Orbiter XMRs was never meant to chase interstellar visitors. Its job is to map the Martian surface in sharp color, tracing landslides and trying to find subtle changes in dust and frost. When you point it at 3I Atlas 30 million kilometers away, the design becomes a limitation. Each pixel on Cassis covers roughly 340 kilometers at that distance, enough to swallow entire Martian volcanoes, let alone a comet nucleus that might be only a few dozen km wide. 11.36 microns is the camera's resolution in radians per pixel, which sets a hard limit. No matter how flawless the focus or how long the exposure, anything smaller than a pixel becomes distorted. Its light smeared over the sensor. Nick Thomas, principal investigator, referred to it as a stretch, even if you want it to be detected. The comet was at least 10,000 times fainter than the features on the surface that Cassis eyes was built to image. The team took long exposures, tuned the tracking, and pressed every ounce of the signal from the noise. The outcome, a muddled dot, was not a cover-up, but a technical limit. The coma, a cloud of gas and dust thousands of kilometers in width, 1 kilogram, blends into the background, while the nucleus itself is lost entirely. The physics is unyielding. Even with the best equipment at these distances, what Mars can only confirm is the comet's presence, not reveal its secrets. The public wanted a portrait. The camera was only able to provide a fingerprint. The next hope for detail would need to originate in a different way, either a new orbit or an instrument altogether. Here eyes, the high-resolution camera on the Mars Reconnaissance Orbiter mission of NASA, was supposed to be the ace up the sleeve of Mars imaging. Its optics can map rover tracks from orbit, and at 30 million kilometers, it indicated at least a glimpse possibly of 3I Atlas core with just a few pixels. However, as the flyby progressed, here eyes became dark. The shutdown of the US government, which commenced on October 1st and froze the entire chain. There are no command uplinks or status logs, no public data releases. The official channels stopped talking for days. Amateur astronomers, professionals, and students alike scoured the Here Eyes archives, awaiting any indication during the campaign. Nothing appeared. Even the planning documents, typically kept public in advance, were missing. Utilizing NASA's feeds frozen, Mars Reconnaissance Orbiter was the subject of speculation. What about other eyes? Zhengwen-1 orbiter from China and MORI over the UAE's Hope mission both followed the approach of the comet, yet neither issued statements, images, or even a rejection. The silence got worse. The government shutdown was cited as the obvious offender, but other people questioned why the space agencies instead of 3 across all continents would be silent. In the absence of data, rumors filled the gap. More people waited for an answer every hour, paying attention to what was missing. Not only a sharper image, but the sense that the world's best cameras were being muzzled. Iris's absence became the story. The internet was left without the crown jewel, hungry for outside evidence, and every unanswered question fed the suspicion that something was being kept from view. Within minutes of the European Space Agency releasing the image of 3I Atlas blurry dot, it went viral. War broke out? Astronomers from the community, from Italy to Japan, sent their own postage stamp versions. Some had substantial stacks of dozens of frames, some of which used AI upscaling filters promising to reveal hidden structure. By October 9th, the internet had divided into 2 groups. One group claimed to see a sharp core, maybe even a hint of a tail or jet, arguing that backyard telescopes had outperformed an orbiter worth €1 billion. The other warned that each new detail was an illusion, a ghost born from overprocessing and wishful thinking. Maya Trin, a famous hunter of comets from Melbourne, where she rose to become the first camp's voice, published a sequence of more processed images than the last, with annotations pointing to what she called streaks that weren't random within the nucleus. Her posts racked up tens of thousands of shares, fueling a flurry of speculation regarding whether the advantages were either absent or hiding. But professional astronomers resisted, publishing side-by-side comparisons and running simulations. They demonstrated how stacking weak frames could amplify the background, hot, vibrating cosmic rays, and noise pixels into an erroneous structure. AI, they argued, made up scaling only sharpened the artifacts, not the science better. The discussion became technical fast. Sigma clipping, for instance, deconvolution, and pareidolia trended on forums as people attempted to reverse engineer the truth from raw data. Some emphasized that even a flawless stack at Cassie's 340 kilometers per pixel scale could never even remotely resolve a comet's nucleus. Of this size, the sharpest amateur photographs, frequently relied upon when tracing back to aggressive enhancement, introduced more inquiries than responses. With each new processed frame, the boundary between illusion and discovery became muddled. The internet's thirst for information outpaced what the data could honestly provide, and the demand for transparency and strict analysis became more audible. If there were something to see, more would be required instead of using software tricks to show it. Posts from anonymous users began to appear prior to the end of the first ESA frames trending, as the ecosystem of rumors' demand for actual data also increased. The internet's appetite for answers now depended on the following round of measurable facts: math about trajectories, radio signals, anything that could be tested. Until then, the burden of proof remained with the applicants, not the doubters. Mallory Lefferland, the shift in Perseverance lead, confronted an issue that was out of place on the agenda for the mission. The nave of the rover cam wasn't built to chase comets, let alone one passing Mars at nearly 90 miles per kilometer per second. However, on October 7th, she approved a 10-minute special sequence of continuous shots of the sky in an effort to capture evidence of the three-eyed Atlas as it tore through Yezero's field of view. The raw frames showed a single small streak. It was barely larger than a pixel wide, stretching diagonally across the picture. At first glance, it appeared to be like a glitch in the computer or a cosmic ray. However, the timing matched that of the comet's predicted pass within a matter of seconds. The smear's mathematics were straightforward, however, the repercussions were not. At 90 kilometers per second, 3I Atlas would cover about 54,000 kilometers in 10 minutes, which is the same length as the streak on the nav cam. If the exposure lasted the full sequence, the streak fit the model for blurred motion, a far-off object fast but too faint to be seen by one frame, but it shows through as a smear when over the course of time. But there was a catch. If the camera had captured just one short amount of time, the source would need to be much closer, possibly even orbiting Mars, to produce the same length streak. Without the original FITS headers at hand, the duration of exposure and cadence remained contained within the rover's logs. Every calculation relied on the absence of that detail. Was this the comet or something else, an object flashing through the sky? The decision made by Lethelin sparked a hazy rumor into a claim that could be tested. The streak from the navcam became the initial hard number in an ocean of speculation with a 54,000-kilometer uncertainty. For the next round of radio listening and checks for trajectories, the math would set the standard for what was considered evidence and what was nothing but noise. A path that runs from Jezero crater to the 7th of October was pretty direct toward a famous spot in the sky, the WOW signal. In 1977, a radio telescope at Ohio State picked up a 72-second explosion at 1,420 MHz, the hydrogen line. Its source was unable to be located, but the coordinates lingered in the sky. Now, with 3I Atlas passing through a few degrees of that patch, the synchronicity was impossible to overlook. Forums brimming with back-of-the-envelope math on the amazing transmit signal strength. 600 astronomical units away, you'd need at least half a watt, and possibly 2, if a dish was pointed directly at Earth. That is the result of a significant power plant beaming through the void. Yet, for all the talk, there is no public observatory released data from the hydrogen line flyby. In consistent listening campaigns, there are no raw spectrum dumps. Even a negative outcome, not the silence. Now, only optical. Radio was also used. The question hung in the air. Using the geometry lined up and the math on the table, why didn't anyone attempt the simplest test? On October 29th, 3I Atlas slipped from Earth's view behind the sun's perspective before turning into a glare so intense to the point where the finest telescopes became blind. No observatory on the ground could follow it for nearly 40 hours. Solar elongation and the angle of the comet from the sun decreased below safe levels for everyone except the most shielded instruments. Throughout this blackout, each theory gained new ground. Some astronomers predicted natural eruptions or the possibility of a breakup for comets under stress from the sun. Others pondered aloud models of scanning orbits if a deliberate action or maneuver could be taking place invisibly. The Galileo Project, a team dedicated to looking for evidence of non-natural technology, constantly announced a watch on all available radio and optical channels, hoping for a deviation from the norm as the sphere with a rounded perihelion approached the primary event, leaving the world with only hypotheses and models. When 3I Atlas reappeared, its brightness, direction, and any additional fragments would become the subsequent challenge for both nature's unpredictability and human limitations in surveillance. Early November brings a checklist of 3I Atlas tests. Astronomers turn to brightness curves looking for sudden drops or increases that may indicate fragmentation. Orbital models use fresh data to check for evidence of jets such as minute deflections, outgassing, or something else entirely. Each measurement is a pass or fail. Does the comet's light go out as expected, or did it break up into pieces? Predictions of trajectories are examined against the reality, seeking any unanticipated change. In the meantime, the JUICE spacecraft is waiting to be observed in the window at the end of the month. Its instruments promise a fresh perspective. However, Earth will not receive the raw data until into the year 2026. In the meantime, every change in the comet's path or brightness provides an indication, and each delay in the release of the data keeps speculation about what survived the sun. The sky of October did not belong to 3I Atlas alone. Just days before the Mars flyby, a comet close to Earth item categorized as to O-5 TF skimmed past Earth before entering the GPS satellite's orbits without warning. A few meters wide, the asteroid eluded all significant surveys until it was close to the sky. A call to mind that even in today's era of all sky surveillance, invisible can still mean small and swift. In the meantime, two comets formed their own unpredictable directions. See 2025. A sixth lemon began to shine in the weeks before schedule, hinting at a possible outburst. See 2025 R to SW drew close attention, just 0.26 astronomical units away from Earth, promising a visible tail and worries about breaking up all at once. Each occurrence demonstrated the limitations of current surveillance, where the next surprise can originate from any source at any level. The universe, the lesson, is packed with near misses, and our watch is never complete. On the 7th and the 8th of October, the European Space Agency made available the first official images of 3I Atlas, just a single blurred pixel sparking global discussion and demands for transparency. A minute detail was a result of the technical limitations of Cassini, not intentional suppression. Still, simultaneously, HiRace remained silent. Hope and tan when one missed important data points and explained. Despite amateur images going viral and persistent rumors about strange emissions or precise movements, there is no official support for these claims by the evidence. The streak from the Perseverance navigation camera matched the anticipated blur of motion for an object traveling at 90 kilometers per second, but alternative explanations cannot be completely ruled out. As Atlas disappeared behind the Sun at perihelion, observers looked to the beginning of November for evidence of shifts in trajectory or fragmentation. The delayed observations of JUICE and the recent near-Earth object close pass of 20 to 5T emphasize the difficulties that persist in keeping an eye on visitors who come and go quickly. The real character of 3I Atlas remains unsolved, highlighting the open limitations as well as the urgency of planetary science data.